Hi, and welcome to the next video here. It's called A1 Injection, and it's a part of Owasp Top 10, which is one of my favorite projects there is for web application security. But before we start this, I'm gonna say a few things, and because this is the first video in the Owasp series I'm creating, I need to point out that Owasp is not a definitive guide to security in web applications. It is a very good guide to getting started with security, and it does address the top 10 most not verified, but other companies told that we found these security flaws, interviews, research. The top 10 list is just the top 10. Doesn't mean that there are not a top 15 or top 20 for web application security. So where does it end? Well, it doesn't really end. It's about being curious. It's about not believing to the sentence after the period. You need to continue studying and continue to read further on to learn new ways to compromise. You need to know how to compromise in many ways before you really understand why you need to do it. But as Owasp Top 10 also states, you do not need any experience with hacking in order to write secure web applications. However, I would say that it is a really good idea to have some experience with hacking, because then you know why and you understand it better, and you have probably a much easier way to tell others about why this is important. And it can be really difficult to tell others, especially your boss, why security matters and why he should or she should give you a lot of funds to actually implement better software or to fix old legacy code. Many different solutions. All right, so the introduction about this is the slideshow was focused on injection, and I will focus on mainly SQL injection, and a little will I mention about command injection. And we will also discuss security in a more broad perspective to better understand what it means to implement these SQL injection preventions and command injection preventions to your software and your system. In this case, my examples will be written in Java, and it will be an ongoing style throughout all my videos that I'm not going to stick to any language. I'm basically just gonna present in whatever language I found it interesting to do it in. So these slideshows can be used for teaching as well. If you wish to do that, I suggest that you read up upon something called action learning, which is something that I do in my class teaching. So let's continue. The whole agenda is a general introduction to security, what is Owasp Top 10, and the application security risk A1 on the Owasp Top 10 list. The learning goals for this is to better understand the term security in an IT context, to understand how to follow security guidelines. In this case, it's Owasp Top 10. To understand what injection vulnerabilities is, and this is specifically SQL injection, and injection vulnerabilities in general. And of course, you need to be able to understand the CIA triad. Now, because this is the first video of the Owasp Top 10 series, I'm gonna introduce a bit more than just the A1. So this is why we also focus on understanding what is security in an IT context, and we're gonna use the CIA triad, a very popular way to identify, to communicate about security with the C, the I, and the A, which stands for confidentiality, integrity, and availability. So let's continue and get started with the slide for real. So of course, some sources I use the Owasp.org, and there are some interesting points to look at on this GitHub repository. So basically, the things that I'm talking about primarily comes from Owasp.org. Of course, the CIA triad talk and the security in context is something that I'm gonna present to you. Some of the things that I learned during my education. Okay, so the general introduction to security. What is security, basically, right? It's a very interesting term because it means many things based upon the context. So whenever you're going to implement security to some sort of, software solution, or it could be physical, it could be some code, it could be a locking mechanism, it could be basically anything. So I wrote down some roles for you to think about. You have something called a programmer. Now, that is basically software. It could be an HR employee, human resources. That could be something about knowledge, right? A doctor. Well, a doctor have access to confidential personal data. A doorman, it could be physical. And a system, it could be like a computer or a collection of computers, servers, rack, whatever, many different things. But let's focus on computer security because this is what I'm gonna primarily talk about. So depending on how you're gonna implement security to whatever context you're working in, you need to understand the context you're working in. So the very first step is saying, well, what is the context of my system that I'm working on? And it could be a server running on the internet, serving some web server or whatever service. Okay, so I want to make sure you understand that computer security is an ongoing process dealing with confidentiality, integrity, and availabilities. So to broaden that a bit more, and before I change the slide, the CIA triad is really one of the better ways to talk about security because anyone can relate to the word confidentiality, integrity, or availability. Your boss understands that you need to keep your data confidential, right? And I guess your boss also will understand that you need to keep your data safe. So you keep it. How can I say it? You have to make sure that the integrity is well in place, right? And the availability is all about how can we make sure that our service is always online, depending on security rules, and what about breakdowns and many different things. So let's change the slide and see what happens now. So there are some other areas about security, right? We need to focus on. It could be physical security, as we talked about, information security, how to store data, how to make sure that your information is well protected. There are some roles called the DPOs, like the data protection officers, and they would probably and primarily focus on information security. Application security fits more to like the role of a programmer, and cloud security could be, well, it could be anyone with an interest in a little, setting up and working environment, or just hosting your business in the cloud. So you need to know about how to make sure that your cloud solutions are actually safe. Mobile security, network security, those two go hand in hand in many ways. Many would also say that a cell phone or a smartphone or a mobile, whatever you're going to call it, is basically also just a small computer that is handheld. And that is true. However, since it kind of acts as a portal to many things these days, it's credit card, RSA keys, and whatnot, right? We need to treat a smartphone a bit differently from a normal laptop or desktop. But in essence, it's kind of the same as normal PC security. Network security, okay, is something a bit more advanced because that basically means that you need to be able to read the traffic on the network as well. And do you actually send your packages throughout the network in a safe and well set up manner? Human security is one of the more serious topics involving social engineering. And I guess many of you know the old Kevin Mitnick story, and that is one of the primers in social engineering. However, I would say focusing on human security is a must because anyone can be tricked into giving false information to a potential hacker. So I usually explain this triangle because it kind of puts things into a perspective. So this is what is security for developers. Where to put the star. So if you focus on it, that you have security, functionality, and ease of use, and you have this triangular shape, and you can put the star somewhere. I would like to ask you, where would you put the star? Would you put it in the middle? Or would you put it all the way up to security? Or how would you do it? Let me explain this to you. If the star is all the way up to security, it basically means that your application or whatever it is very secure, but it's very hard to use because the functionality is really restricted and the ease of use is really bad. So I'm not saying that it couldn't work, but I'm just saying that many users might even quit in anger just because of so difficult to use. So I would like to say that no, I wouldn't necessarily just place the star on the top of security just because and for the sake of better security. That doesn't really make a lot of sense. So I would say now comes the difficult part. Based on the context, you need to place the star correctly. Okay, so if you're creating a web application, let's say some debate website where you can ask questions and answer something to it, and a thread forum answers, polls, upload some images, stuff like that. I would say I wouldn't necessarily put the star much up, but to different kind of features, I would create different kind of models. So let's make up a situation here. If we assume that we have an upload functionality on our web page, and I'm going to upload an image, I would say that I'm trying to do something that is a bit more sensitive. I'm trying to upload a file on the server. This doesn't sound safe, right? Well, it can be, but just out of the box, no, it's not that safe. So I would say that I would increase the security level for upload functionality. But just for using the website, I'm probably more prone to do less functionality and more ease of use with a really good set of security. So I would probably move the star to the right a bit, and in some cases move a little up and a little down, depending on with what kind of data the user is being presented to. So, and of course, if the user is trying to access some very personal information about themselves, there could be a little more security, asking them about a secure PIN or login again. Many different things are set into place these days. So I hope you understand that placing the star is important to do. And it's not something you do once. It's something you do for whenever you, for example, change your security level of your application, that you log in, for example. That is a change of security level. Or you want to edit your personal information. That's also a change of security level because you're requesting access to edit sensitive data. So of course, create different of these security models depending on what you're doing, and try to identify if a type of action is a little more sensitive than others, and create a new security model for it, and document, describe why and what you're going to do about it. Of course, you also need to understand how to communicate to management, and you notice me smiling a bit now and maybe laughing because management is where security stops in many cases. Many programmers, many people, did I say many? Try to get funds and resources to actually implement security in that project or company they work at. And they got stopped by the management. And it could be just your first local stop, like the first boss or the level or whatever chain of command that you have to communicate through. And I would say that most management and bosses probably think about these three terms: time, quality, and cost. So let's be fair, that is what they're hired for, right? They are hired to make sure that you do your quality job in the time needed, and that you are getting the money for whatever work. So I'm not meaning that you should be paid. Of course, you should be paid, but that your time is actually something that can be um, giving the company revenue. So you need to earn them money. So time, quality, and cost is three terms that I came up with that I figure if you're gonna try and get more time for implementing security, it basically means that you will earn them less money. However, it will raise the quality. So you need to some way communicate it out to your boss that the quality is what they will get. And if you don't get the quality, you might have some security breaches. And this is where a showcase of some hacking or some security flaw you found or you already is aware of in the company. And you should, of course, communicate that too and not just do it without telling or asking for permission, because it is illegal to hack or compromise systems. Please do not do that. Always ask for allowance before you're doing anything that you're not hired to do. And just for the sake of this image, I do not own it, so I just use it, and credit to whoever made it. It's a splendid image. There are many different technologies to implement, and in many cases there's not enough time to test everything. So asking for resources to test and implement security is something that can be very difficult, and you could probably feel like that you are that little person being yelled at by a boss. So by saying that, you need to, well, find a way to ask more resources. And that can be real difficult. I understand that. And I still find it difficult these days. But as a total normal person to you, I suggest you just take a talk with your boss. And just say, listen, I know this is going to cost something. I know I'm not going to bring in any revenue, or I'm not going to earn you any money, but it is something that is needed. And in many big companies, they will understand. These days, it's a lot more easier. Like 10, 15 years ago, it was like a living nightmare. So this leads to the next point. It's called built-in security. You need to build in security from the start. Some parts of security can be wrapped at a later stage, of course, but you can't need to just implement it from the start in your solution, in the architecture, because else you will just be mending it with some sort of bandage, and it will not really work. Of course, you can always implement a HTTPS certificate at a later stage, but that would be like really bad idea. You need to run the HTTP certificate, the TLS, SSL stuff going from the very start of publishing your web page. So try to think about security from the start. If you're a programmer, you should definitely think about your abstraction layers, how to handle cross-site scripting, cross-site request forgery, SQL injection, authentication, so on and so on. Now I know this is the first slideshow of the Owasp, so this is also why I'm talking about different kind of vulnerabilities that I haven't even covered yet. So whenever you're done with all the 10 slideshows, I suggest you go back to this one and revisit some of the points to how to understand and implement security in like a broader perspective. Yes. So some things can be applied after, but again, I would say like the SSL TLS certificate, you could probably implement some two-step authentication, or you can probably add on a Google Capture, but again, I wouldn't really suggest it. It's just if you really have to cut short somewhere, it should not be on the SSL TLS HTTPS certificate. You should never cut short on that. And it's really difficult for me to even say, but some things can be implemented after. So don't cut short anywhere. It's a bad idea. But some things could be implemented after. Of course, anything can, but it's just more difficult whenever your system is done and trying to get another, feature inside a lot of functionalities. It's very easy to miss something, and actually trying to fix, amend, it doesn't. You should build in from the start. That's the better way. So we have the CIA triad here. It stands for confidentiality, integrity, and availability. The C for confidentiality is about how to keep your data and secret. And keeping a secret is actually pretty difficult. Try and think about it. If you know something and you're not allowed to say it, but sometimes you need to do something and that kind of reveals what the secret is. How difficult will that be? In a way, it could be manageable, but in many other ways, it's going to be very difficult. So I would say keeping your data secret and your secret is difficult, but there are different ways you can do it, of course. Ensure no one authorized can access the data. That is about the access part. The integrity is protect against modification of the data and the system, and ensure the data has not been altered. So basically, confidentiality is all about how to not give access or to give access, and the integrity is about making sure that those who already got access or maybe do not have access can do something with the data or in some way alter it or make alterations. Because let me just be clear, some security flaws can be very abstract and it doesn't directly give you access to a resource, but indirectly you can get access to it, and that could break the integrity because you can actually make another system do some alterations to a restricted part of the system containing sensitive data. Availability is all about ensuring authorized people can access the data they need when they need to. So that's very difficult because let's assume that you're under a DOS attack, distributed or just denial of service, DDoS, or distributed attack. Then of course you kind of need to figure out a way how to be online, how to make sure that the people online can access your data. And if your servers are down, do you have backup servers? What are you going to do? So that's what this is all about. All right, so that kind of concludes the very first part. And I know it's been long, it's like 20 minutes, but sometimes, it just takes a bit to explain what is security in a specific context. I know it's going to be a bit theoretical, and it's been a bit theoretical and a bit abstract, but hey, it's security. It's not like pounding a nail down in a piece of wood. So yeah, you need to think it in from the start. So what is Owasp Top 10? To put it short, it's the Open Web Application Security Project. It's a non-profit foundation that works to improve the security of software. And there are many members, tens of thousands of members all over the world, the globe. Tools and resources, and you also have a community networking, education, and training. There are many different things on the web page. You can find something called the Juice Shop, which is a website you can download and hack and compromise. So just to not take all the fun out of exploring the website yourself, I'm going to change the slideshow and focus a bit more on the 10 different application security risks that they actually talk about on the web page, the top 10. The first one is called injection. You have broken authentication, sensitive data exposure, XML external entities, broken access control, security misconfiguration, cross-site scripting, insecure deserialization, using components with known vulnerabilities, and insufficient logging and monitoring. This slideshow will talk about the first one, injection, so I suggest we change the slide and continue onwards to that. Application security risk. So A1, injection in general. Most input on web pages, and this is Owasp, so it's web application security, does point to some part of the database. But of course, not every single point of input does reach a database. However, if it does, you have a possible injection issue. And if you do have a possible injection issue, you need to take care of it by using prepared statements. And you also need to validate whatever data and make sure that you don't send it to any preparation of a query for the database, because let's say that you expect an integer value and you get like 50 characters or something. No one have a 50 character long, 50 in length number, like 59s. That's gonna be a very, like a billion type trillion, it's too many numbers, too long a number. So of course you could probably cut it short by just measuring the amount of the length, the size of the data you get. So if you expect a number in between 1 and 5,000, let's say that's the maximum and the minimum, well, you can just ask if 5,000, that's four places, like 5, 0, 0, 0, so that's 4 numbers, 4 in length. And if it's more than 4, just say no, thank you for that. And then if it is numbers, you can try and typecast it. And if the typecast is okay and you actually get numbers out of it, no exception made at all, you can set it all through to the prepared statement, and then it will try and execute it. That could be a really good way to sanitize and work with your data. You could also have something called command injection, and it's kind of the same. Command injection, SQL injection, injection in general. There are many different kinds of injection. If your web page is allowing you to do some commands in some way, because it's a administrator login with some access to system commands, you could have command injections. And again, if you don't sanitize your own data, injection could be one of the big issues you could have on the web application. So how to prevent injection? Well, basically you need to sanitize your user input, and this is context based. So you need to make sure that whatever sanitized method you're using or sanitized functionality, it needs to sanitize the data to wherever it's going. If it's going to a web page, you need to escape all your special characters to HTML entities. If the data is going to a database, I would say save the data raw and then output it and sanitize the data after that. After you select it from the database, then you can sanitize the data to the right context. Because if you sanitize your data inside your database, then you have sanitized data in your database where you have escaped characters and all different kind of things and whatnot. And whenever you're pulling it out from a database, you need to do exact the same desanitization of the data. And if you get that one time, you might have compromised your whole system by actually outputting data that is compromised. And this is a really bad idea. User prepared statements don't allow more access than needed for one user role. So use the least privilege possible. Don't run your stuff with the root access or super admin. Create a user with the exact amount of needed access, least amount of needed access as possible. Keep data separate from commands and queries, and use whitelisting instead of blacklisting. That is the general suggestions from the Owasp, and of course the list goes on, but this is the 5 most interesting parts that I wanted to bring forth to you today. So this is an actual SQL injection showcase. So we're looking at some Java code here below, and it says a method to grab the get request variable user ID sent from the browser. All right then. So we create an integer called ID, and we set it equal to request get parameter user ID. Now I know that it might even return a string. I didn't really look it up that much in Java, but get parameter could be returning a string. So you Java experts might say, oh, we need to have a string ID instead of integer ID. Well, this is just an example, so it doesn't really matter. What happens here is that you take a parameter variable from the HTTP request from the client and put it directly into the select statement down below. That's gonna select all from users when user ID equal to, and then you just concatenate the ID variable to that SQL query. It's a very bad idea because you're putting unsanitized data into an SQL statement. And that could be, it is a SQL injection vulnerability that is being opened for in this case. So you need to use prepared statements. You need to look up on the whatever language you're programming in, how can I do prepared statements to the database. So let's look at some code. Is this secure? You might think, well, I do have a comment say no input validation. This is completely as it is. I know this is a PHP example, so this is just another example of insecure code that you you have some input and some argument in some way, and the first line you concatenate it or put it directly into a SQL query, and you execute it, so you have some SQL injection possibilities here. So it is not secure at all. You could insert something like that, and if you do that, you're gonna present the super user access to him, and it will basically, well, be really bad for you. So that's an actual SQL injection vulnerability we have right there. Another one could be like that. We have another insecure piece of code in PHP again, where we just set some size equal to another size, and this is if this happens, we can just do something like that and do a union select and concatenate username and password from whatever user table we have. Of course, this is a more final attack, and if we needed we would need to do some footsteps before that in order to know the table column name and table name. But of course, this is just an example, so let's assume that you already know those column names. A more secure way of doing query could be something like this. I know it's not prepared statements, but let me just say that if you're having an issue finding a way to do prepared statements in the language you're programming in, or some reason like that, there are other ways you can protect or sanitize your input. Of course, it's all about the sanitation process. So if you're setting the type in PHP and the offset variable to an integer, it is somewhat safe enough to put it in, but I would still say that you need to do some extra sanitation to it, and I would not suggest regular expression, because regular expression can lead to a denial of service, because it is basically a small language and you can make it intercept a lot of characters and kind of go in loops, and it's a more advanced topic. Anyways, this is a bit more secure, but it is not in any way the best way. So this is just, if you cannot do prepared statements, think of different ways how to verify and sanitize as much as you can before you insert whatever query into your database SQL statements. So this is another Java example, and this is an example of prepared statements. The code should be somewhat correct. So you have this parameter you're getting from the user and user ID. You put it into a variable, the SQL statement. Instead of putting the value after user ID, you put a question mark. And that question mark will be interpreted whenever you do the set string 1, and the 1 here means the very first question mark. If you had several, conditionals in the SQL statements, you would have more than one question mark, and then you would have to choose the right order. So if you had like one question mark, it's number 1, and you have blah blah blah, another question mark, then it would be number 2. That way incremental. And the ID would be the ID variable here, and this would be a prepared statement, and in many ways this would be secure enough to execute. That would be a way to execute prepared statements. I know I wrote in the top it's pseudocode. It is a little bit missing here and there, but the overall idea of how to create a prepared statement is well enough shown. Alrighty then. What you could do if you want to get a good start with SQL injection and starting your ethical hacking and experience, you can go to Try Hack Me. I'm not a sponsor. I just like the webpage a lot. I'm actually also registered there. I would suggest you go to Try Hack Me and create a profile. It's a really good place that will teach you more than enough to kickstart your cybersecurity profile. And LinkedIn, you can put stuff on LinkedIn, you can get certificates, you can, kickstart your whole career that way. That's a really good place to do it. So you can also do something called the command injection. And command injection is very, very bad, because if you have that, let's say that you have some way of you can ping another web page or ping some IP address. That's what you do, right? The ping command, right? Then if you didn't sanitize the input, you can add on, let's say, a pipe as in Linux, and it's a semicolon in Windows, and do some wget, which is download whatever this backdoor shell script. And if you have a direct access to the actual server, then you can just execute it, and well, all of a sudden you have a backdoor, and you can download code, and you can concatenate commands and do different kind of things. So it's a really bad thing. If you actually, if you must do and give access to commands through a web application, make sure that you use some correct method to escape your shell arguments. And in PHP, I know it's called escape shell arguments, if I'm not mistaken. And I'm not 100% sure what it's called in Java, but there are many different kind of solutions to this. Escape your data, sanitize it, many different things can be done. And yes, I said that. Semicolon Windows and pipe for Linux. Alrighty then. Should you use it or not in your application? Yes and no, right? So there's also always a risk, as I told you before, and I would say if you can avoid it, then avoid it. That's the better idea here. Okay, so the next video in this Owasp Top 10 will be, of course, the broken authentication video. And I will talk about what broken authentication is the A2 top 2 in the top 10 of the Owasp videos. And until then, I hope you learned something, and I hope you can use my video and my experience to something. I know it's a bit theoretical and without a lot of showcases, but this is how I learned security, and I hope that you will get as much out of it as I did. Thank you for now. See you. Bye.